welcome to today's class. Today we'll be looking at applications of vectors analysis. Down it will lead us to gradients, and those gradients we'll be talking about core, divergence, and so on. So let's just be attentive, and if you have any question, don't hesitate to ask me by raising up your hands. Then I'll give you the opportunity to ask your question, and then from there we can all be on the same page. Can you see my screen, please? Can you all see my screen?
Yes, sorry, sir. What do you say the topic is?
You said what?
What do you say the topic is again? Application.
It's just the application of what we've been solving before now, of vector analysis, of vector differentiation.
Okay.
We started it before now, and we just need to solve one or two applications. If you check this now, we only solve this and this. We solve partial derivative. We saw where we have cross and dots, right? So what about where we are going to apply them? How do we apply them in a real concept? What does it mean when you introduce it to particle? What does it mean? So let's look at a particle. A particle moves along a curve. I believe you've seen questions like that before now. So let's look at it. A particle moves along a curve whose parametric equations are, we have x equals to e raised to power minus t. We have y equals to 2 cos t, 3t. Then we have z to be equals to 2 sine 3t. So where t is the time, where t is the time, let's look at it. Where t is the time, then what other things do we need to put here? Hey, let's look at what they asked us to determine here. A determine its velocity and acceleration at any time B. Find the magnitude of the velocity and acceleration at t equals to 0. At t equals to 0. Okay. So let's look at this. What are the things we need to do here? The solution is here. The first thing we need to know is the vector, is the position. Let's look at the position vector R of the particle we are talking about. Is R equals to xi, don't forget the component, plus yj and plus zk. So we need to add all of them. Don't forget you are given x, y, z. Add all of them together. S contained with I, Y contained with J, and Z contained with K. That's their component. So our R will be e raised to power minus ti plus 2 cos 3tj plus 2 sine 3tk. Remember, the first question says, determine the velocity. And we all know velocity is the r dt. The velocity is what? The r dt. The first derivative of r will be, we can now say that we have our v, our velocity, to be equals to dr dt, which is same thing as d dt of exponential minus ti plus d dt two cos 3t j, then plus d dt 2 sine 3t k. So here we have, if you differentiate exponential minus t, what do you have? You still have minus exponential minus t. You remember? I. If I differentiate cos, it will give me what? Minus sine. So minus, it will give me minus 3 sine 3t, right? But you have to here. It will be minus 6 sine 3t j. Then if I differentiate this, it will give me plus, it will be plus, right? But if you differentiate sine, it will be cos 3 cos 3t. So 3 times 2 will give me 6 cos 3tk. So that is our velocity they asked us to calculate. Any question? So don't forget the question says velocity and the acceleration. So for acceleration now, we have the velocity to be this, but the acceleration will be the acceleration is a, which is a d square r dt square, meaning differentiate your velocity second time. You differentiate your velocity second times, it will be the one that will lead us to this. So for us to differentiate our velocity second times, we know the velocity is here. Here is our velocity. Differentiate it second times. We're going to have, in this case, will be minus exponential. Remember, minus times minus will be positive, right? But let me put it this way, minus exponential minus t I minus, You know, when you differentiate sine, it will give you cos. It will be sine 3t, will be 3 sine 3t, making 3 multiplied by 6 will give you what? 18, but I can do it this way, 6 in bracket, 3 cos 3t, j, then minus 6 in bracket, 3 sine 3t, k. So if you open this bracket, our a will be minus times minus exponential minus ti minus this one will be what? 18 cos 3t j and minus 18 sine 3t k. So that is what they asked us to do. Remember, acceleration, differentiate it twice. Velocity, you differentiate it once. First derivative, second derivative will lead you to acceleration. Then, the second question says what? The question B says, find the magnitude of the velocity and acceleration at time t equals to 0. At time t equals to 0, you see it here? At time t equals to 0. So, you have to do two things at that point. B will be what? At t equals to 0, the r dt will be equals to what? So let's go to, this is the r dt, right? This is the r dt. Let's substitute 0 there. When you substitute 0 here, let's put it one after the other. We have minus exponent, okay, the r dt will be, which is equals to minus exponential 0 I Are we following? Minus 6 sine 3 of 0 j plus 6 cos 3 of 0 k. I know exponential 0 will be 1, which is minus I. Everything sine 0 will be 0. But by the time you do, cos 0 is 1. 1 multiplied by 6 will give you minus, will be you plus 6k. So that is what we have. So you do the same thing for the second one. At t equals to 0.
Hello, sir.
Yes, go ahead.
Please, I'm lost.
Where?
You said anything times 0 is what? Is 1.
Just punch your calculator. Sine 0 will give you what? Is 0.
Okay.
Sine
Thank
0
you.
will be 0. 0 multiplied by 6j will be 0.
Will
That's
be
why
0.
j is absent here.
Okay, sir.
But cos 0 is 1. 1 multiplied by 6, 6k. So that's why we have 6k here. Have I answered your question?
Yes, sir.
The square r, the t squared will be equals to, if you substitute into acceleration, this one, what do we have? We will have it to be I minus 18k, 18j, because k will have been to 0. So, now, that is not the question we asked to solve. The question says we should find the magnitude of velocity at t equals to 0. Magnitude of velocity at t equals to 0 is what? Remember, the formula for magnitude is what? Formula for magnitude is depending on what they are asked to calculate, let's say the R, the T, the magnitude will be at T equals to 0, don't forget, will be square root of whatever you are given. Let's say you are given, what do we have to calculate? Please talk, guys.
We have to calculate the magnitude of velocity, sir.
Okay, so it would that be what? Minus 1. What is the formula for magnitude? Is
S
it
square. Okay.
Yes.
what?
S square plus Y square
X squared
plus Y square. The square root of
plus
S
Y
square plus Y
squared.
square. Z square.
Right. Why are we not putting IJK? Because IJK will have turned to 1. Do you agree with me? Because
Yes,
they
Yes,
are
sir.
already square. Not minus 1, no. But in this case now, we have minus 1 for I plus 6 squared for K. The final answer will be what? Square root of 37. Any question?
Hello, sir.
Go ahead.
So please, I have a question where you wrote minus exponential. Please, I don't know if you can go back a bit.
Which of them?
Okay, at t equal to 0, where we will have my
Is here.
yeah, exactly. Where we have minus exponential 0i. But I thought anything raised to power 0 is 1. That means minus.
That is what exactly you got it. Not anything raised to power 0. E raised to power 0 at this point. Punch your calculator. Exponential raised to power exponential 0 is what? 1. 1 multiplied by I is I. That's why you see this. Have I answered your question?
The exponential is carrying a negative. That's why it's minus I.
That's because you see there is a negative at the back of exponential. Not because there is nothing where you can write minus exponential minus 0. There's nothing like that. It's exponential 0 because everything here has turns to 0. Are you getting it?
Hello, sir.
Yes.
Sorry, I was disconnected. I'm asking what we have this minus exponential 0i. And the minus exponential 0, I thought it's supposed to change to 1.
You
Not
are
exponential.
correct. It's 1. But 1 multiplied by anything is that thing, right?
Yes, sir.
1 multiplied by I, negative I is negative I. That is what you see here.
Yes, I thought what we are dealing with minus exponential raised to power 0.
Okay, 0 multiplied by minus 2 is what?
0.
So 0 multiplied by minus t is 0. Do you get it?
Yes, sir.
Is that okay? Have I answered your question?
Yes, sir.
So let's do this one. The magnitude of acceleration. The magnitude of acceleration at time t equals to 0 is what? So we have magnitude to be d square r dt squared at t equals to 0 is what? Square root of, put this one there. We have x squared plus y squared plus z squared. Some of you lose mark because you don't write formula. Because you know it, you just go to the solution. Don't do that. Write the formula you are working with, so that the examiner that is giving you grade will know you know what you are doing. So The second one will give us what? 1 squared plus minus 18 squared. So at the end of the day, we have it to be square root of 325. Any question? You can break square root of 325 down as long as you know what, you can punch your calculator and see, just to reduce your stress at that point. Any questions? So I would advise you to use this particular one to solve as many problems you might encounter when it comes to application. They always ask, is it that part they are talking about particle acceleration? You will surely get a question on that area. Any question before we proceed? Please ask your question. If you don't have question, I think we can also proceed.
Sir, I have a question, yes, sir. Hello, sir.
Is it pertaining to the one we solved now?
Yes, sir.
Go ahead.
When we are determining the velocity at any time, I think at that particular place I was a bit I wasn't hearing clearly, so I did not understand how you got the answer, the final answer, sir.
Which of them? Is it B or A?
Now I'm talking about A. I understand B, sir.
Okay, A is just a differentiation. We just differentiate exponential. Look at it now. Here says d dt of exponential of this, d dt of this, and d dt of this. According to the knowledge you had in the calculus, how to differentiate is very simple. When you differentiate exponential minus the s minus t, is like you are saying that you are differentiating all everything here over the t, right? And you write
sir.
your exponential back. That's the meaning. So when you differentiate t, negative t, what do you have? -1. That's why you see it to be negative. Then you multiply it with exponential back. It's -1, but you don't write 1e. We only write negative. This is the answer, right? So, but you don't write -1. We just write -1 multiplied by 1 multiplied by negative is negative. So we just put it negative exponential this. Then you do this one. When you differentiate cos 3t, we give you minus 3 sine 3t. So -3 times 2 will give you 6. Then when you differentiate sine, we give you 3 cos 3t. 3 multiplied by 2 will give you 6 too. So that is what we did. Is that okay?
Yes, sir. Thank you, sir.
Okay, you're welcome. So let's look at another one before we move on. I think they normally ask us again, a particle move along the particular curve. Let's look at that. Another application, a particle move along a particular curve. So I think that one will also be of help to us. Question 2 says, a particle moves along the curve then we have x equals to 2t squared, y equals to t squared minus 4t Are we together now? So, and Z equals to Z equals to 3t minus 5, where t is the time question says find the components of its velocity and acceleration at time t equals to 1 in the direction I minus 3j plus 2k. I minus 3j plus 2k. Now, we just did the velocity now. We know how to do the velocity and acceleration. All we need to do is just to see how can we solve this problem. And let's look at it. The solution will be the velocity first thing, velocity, because you can't go to acceleration without velocity. So for velocity, what do we have? We have the r, the t, which is d dt. I can just write it this way. I know all my components one by one. I know my x, I know my y, I know my t, I know my z. So my x is 2t squared I plus t squared minus 4t j. Don't say t squared minus 4t is minus 3t. It's not the same thing, because this one carries squared, the other one is a single, is not squared. So you cannot, they only have t in common, but not t squared. 3t minus 5k. So we need to solve this problem. How do we solve them? It's pretty simple. Differentiate this one will be what? This will be 4i. I believe you are 4ti. Then differentiate what is inside plus 2t minus 4j plus, when you differentiate this, what do you have? 3k. Because 5 is constant, it turns to 0. But at the end of the day, what do we have here? At t equals to 1, what do we have? At t equals to 1, what do we have? So let's substitute 1 where we have t. That's the meaning. So you have 4 of 1i plus 2 of 1 minus 4j plus, there's nothing t here, there's nothing t here. We just write tk. But in this case now that we have t, what do we have at the end of the day? We have 4i 2 minus 4 minus 2 minus 2j plus 3k. So we have this back. Now, the next thing we need to calculate is the unit vector. Unit vector. Moses, any problem? Unit vector in direction. Don't forget we are given the direction. The direction is I minus 3j plus 2k. So our unit vector in this direction will be the direction of I minus 3j plus 2k is going to be the direction over the magnitude of the direction. So meaning we are going to have it to be I minus 3j plus 2k over square root of 1 squared plus negative 3 squared plus 2 squared. So at the end of the day, what do we have? We have I minus 3j plus 2k over, if you add this one together, you have square root of 14. That is 1 plus 9 plus 2 plus 4 rather, making 14, square root of 14. Then we can now calculate the component. The component of velocity is, in given the direction, is very simple. We know this unit vector. This is our unit. Our unit vector is here. This is a unit vector. So we can now calculate the component. The components of the velocity in the given direction is, remember we know our velocity. We calculated the velocity to be, the velocity is 4i minus 2j plus 3k dot the unit vector. Our unit vector is I minus 3j plus 2k divided by square root 14 root. So for this one, how do we solve this one? It's very simple. That is component by component. Remember, component by component will be 4 multiplied by 1, the other one here. That is this multiplied by this, then this multiplied by this, then this multiplied by this. So you can see the component by component. So we have, the next one will be j. J is positive now. Minus multiplied by minus will give you, we just say plus minus 2 into minus 3, then plus 3 into 2, everything divided by square root of 14. So let's add this one together. What do we have? 4 plus 6, 10, plus 6, 16. 16 divided by square root of 14. Remember, according to, this is radical. Radical means square root, right? You cannot leave the radical as a denominator. You can rationalize it by saying that using the sort. Remember, root A multiplied by root A will give you A. I hope you remember. So if root A multiplied by root A will give me A, I can now rationalize this, multiply both sides by root 14. So if I rationalize this, I'll have 16 root 14 multiplied by root 14 over root 14. So I know root 14 times root 14 will give me 14. Then I have 16 root 14 here. But I can, 2 can go in these 2. 2 can go here in 8, and I have my root 14 over 7. So this will be the solution for this. Any question? Okay, let's move on. Remember, we only solve first one, which is our, we only solve the component for velocity. Please take notes on your exam date when you are given this. Don't mix it together. They are different. So this is acceleration now. You have to pass through the same process in order to get component for acceleration. So meaning you have to differentiate this gentleman again. The one with t, you have to differentiate it again for us to get acceleration. So acceleration will be, let's go to the acceleration. Acceleration is the square r, the t squared. The square r, the t squared. Simply means that we are saying d dt of the r dt. That is the meaning of the acceleration. Remember, we have the r up. The r you have written down will be d dt of the entire, the r will be 4ti plus 2t minus 4j plus 3k. So if you want to differentiate this, what do we have? We have 4i plus 2j, because this will have turns to what? 0. Then plus 0k, because this, there's no t here. It's more or less you are dealing with constants. So, and don't forget, we don't have t here. We don't need to substitute when t equals to 1 again, because there is no t. If there is t, you cannot put when t equals to 1, but there is no t there. So don't forget it. So can we proceed now? So we have there the same process we did the other time. We already know the unit vector. We multiply the component by unit vector. That is the component of the acceleration in the given direction is 4i plus 2j plus 0k dot, the unit vector will be our I minus 3j plus 2k. Everything divided by square root of 14. So when you do this one very well, you should have 4 of 1 plus 2 of -3 plus 0 of 2. Everything divided by root 14. At the end of the day, you have minus 2 over root 14. So when you rationalize this one, it will give us minus root 14 over 7. Follow the same method. Any question, guys? Any question on this application? Any question? I need a response, guys. I'm with you. I can't hear you, please.
Can you hear me now, sir? The first one we solved after the velocity after solving the unit there. The last answer we
Probably you can put a chart there so that that will be better. So that is when you see any of these questions, this will guide you to be able to solve as many problems as possible. Any question, please? The last class we talked about how you substitute the value into partial derivative. But today, also, we'll be moving at a differential operator. Let's look at the differential operator. From the differential operator, it will lead us to another. This is taking us out of more to another area entirely, which we need some of your, okay, someone has sent. Oruma, you are welcome to the class. You need assistance. Okay, we'll talk about it after the class. Thank you. Okay, so let's move on. Another topic says the vector differential. I'll always advise my student, please write operator. The differential operator called del. The del is the symbol of del is this. And del is equivalent to, this is equivalent sign, equivalent to d dx of I plus d dy of j plus d dz of k. and is also equivalent to I d dx plus j d dy plus z d dk. This vector operator possesses a property analogous to those
I guess that's very sir.
yes,
Plus
Emmanuel.
plus k the z. That's the last part.
Okay. What happened to it? Oh, plus.
Yeah, the last equivalent.
Thank you.
Yeah, he said it's r. Okay, sir.
Thank you. So it is useful in defining the three quantity which arises in practical application and known as the gradients. We use this del in when we are solving the problem. You can write this one down. Okay, let's just write. This vector operator possesses properties analogous to those of ordinary vectors. It is useful in defining.
Hello, sir.
Yes,
When you say something is analogous, what does it mean?
it's a kind of example from the word. You can check. Okay, what's the meaning of analogous? According to your dictionary, English word. Tell me the meaning.
Not really. That's what I was asking. So,
No, the meaning. I'm
I think
not
something
saying the
similar.
literary meaning. I'm not saying how it's related. Then I will now relate it to mathematics now. What does it mean to say something is analogous?
Similar.
Similar. That's part of synonymous. So similar to those in ordinary vectors. Are you following?
yes, sir.
Okay. So it is useful in defining three quality or three quantity. Let's put it out. Three quantity which arises or which arise in practical application, the one. And are known as the gradient. The gradient, the divergence, and the curl, the gradient, the divergence, the curl. You can't do vector without doing those three key quantity. So let's take note of that. We will pick them one after the other. Let's first of all look at the gradient. What is gradient is talking about? Then from the gradient, we know the definition of gradient. We know. Then we look at the divergence and we look at the curl. Then we will now start solving the problem with them one after the other. So I hope that is clear. Are we together, please? I need a response.
Yes, sir. Yes, sir. We are together, sir.
Okay, let's look at it. The gradient. Under the gradient, we said let phi of x, y, z be defined and differentiable at each point x, y, z. Just a minute. So we have this definition. In a certain region, of space, that is, our phi defines a differentiable scalar field. A differentiable scalar field. Then the gradient of phi written as this, or we call it grad phi. So when you see grad phi, they are talking about gradient. And is defined by del of phi to be equals to d dxi plus d dyj plus d dzk. Everything multiplied by 5, which is the same thing as is equals to the phi the xi plus the phi the yj plus the phi the zk. Remember, phi that I'm talking about is the same thing as this. That's the phi. So take note of that. Note that the phi defines a vector field. A vector field is defined as a vector field. So also, the component of phi is the direction of a unit vector. The way we solve, remember, they can ask you to find a component. So in this case now, we can say the component of phi in the direction of a unit vector, A is given by phi. Is given by phi dot A and is called the directional derivative of phi in the direction A. In the direction A. Physically, the range normally the rates of change happens to this one too. So let's take note of that in a physical sense. But I would like us to have the definition of the one of divergence too. So before we go into the way we solve them, let's look at the divergence. Remember, I mentioned 3. It can ask you to define gradients, divergence, and the curve. So let's look at the divergence. The divergence is this. We have the divergence to be let v of x, y, z equals to v1 I plus v2 j plus v3 k. Be defined and differentiable be defined and differentiable at each point. At each point of x, y, z in a certain region, in a certain region of space. That is, we define a differentiable vector field. Field with different vector field. Then the divergence of V will be written in this form, der of V. Remember, the der of V, der dot V is equals to d dx. You know the definition of der from the day one. D dj, the y j plus the z k dot v1j, v1i plus v2j plus v3k. So we can now have them together. Remember, I dot I will be 1. So definitely in divergence, you don't need, the component will not happen at that point again. We have it to be d dxi dot v1i will be what? The v1, the x. There will not be any high again. Plus the v2, the y, plus the v3, the z. Take note of that. We are using the principle of A dot B. Note that the V is not equals to V dot the V. Remember, when you prove this one, you know it's not the same thing. Remember, we did that last class. So please take note of that. So let's look at the third definition. The third definition says the core. The core is a bit different. It said if V is x, y, z is a differentiable vector field. Then the core or rotation of V, written as, this is cross, not multiplication, del cross V. We call it del cross V, or we call it core V or rot V, is defined by del cross V equals to d dxi plus d dy j plus d dzk cross v1i plus v2j plus v3k. So you remember the way we solve the problem of cross. So that is where we now use it here. You use determinant theorem, I, J, K. So we have d the x first, v1, d the y second, v2, and d the z third, v3. So for those of us that, if you missed the last class, please go and read. If you missed the previous classes, please watch the video so that you can have better understanding on the dots, on the cross products. So here we have positive minus positive. Then let's find the determinant of this. For I component first, all you need to do is this row 1 will be parallelized. Then the column 1 will also parallelize. So it remains what? D dy v2, d dz v3. So remember, negative is in column 2. Let's go to column 2 again. Row 1 will still parallelize. Column 2 will follow. We have minus j. Then all remaining what? D dx v1, d dz v3. Now we release this one. We go to column 3, which is this one, plus k. So we have d dz, the x, v1, and d dy v2. So let's take note of that. So all you need to do at this point is just to cross multiplication. This will multiply this, minus this will multiply this. So we have our I. So I will be, in this case now, we have d v3 dy minus the v2 dz. I minus the v3 dx minus the v1 dz. That's j, plus the v2 dx minus the v1 dy. So this is k. So now we have the definition of each of them. There are operators. There are ways of solving them. Let's look at those formulas before we go into examples. Then we have formulas. Let's look at this. For formulas, we have, let's say the number 1 formula here says, anytime you have the del of phi plus psi, this is psi, which is equals to del of y plus del of psi. Then 2, when you have del of A plus B will be equals to del dot A Look at it. The first one is not dot. It's just a multiplication. But the second one is dot plus del dot B. Don't put A dot dot. A dot del is not the same thing. Please take note. We proved it in the last time. Then when you have grand of phi plus psi will give us grad phi plus grad psi. So you can see the two. So let's take notes. So number 3 says when you have del or cross A plus B, the same thing as del cross A plus del cross B. Or you can have core of A plus B. The same thing as core A plus core B. So let's look at number 4, says when you have del of A file A will be what? Del phi dot A plus phi in bracket del dot A. So take note of that. They are all useful for us. So we still have a lot of definitions to sort out. However, I was thinking to go into the, okay, we will need them. Let's still write them. Number 5 says del cross phi A equals to del phi cross A plus phi del cross A. You can see it's a different thing. Number 6, del dot A cross B. The same thing as B dot del cross A minus A dot del cross B. Number 7 says del cross A cross B. The same thing as B dot del A minus B dot A minus A dot del B plus A del dot B. So there are instances whereby we will need to do that. So let's take note of that. Number 8. Del A dot B. The same thing as B dot del A plus A dot del B plus B cross del cross A plus A cross del cross B. Let's take note of that. Number 9 says del dot phi, the same thing as del squared phi, which is equivalent to the square phi, the x squared, plus the square phi, the y squared, plus the square phi, the z squared. So this squared is also called the Laplacian operator, from the word Laplace. The Laplacian operator So number 10 says del cross del phi equals to 0. Meaning the core of the gradients of phi is 0. Please take note. They can ask you in your TMA, the core of gradient is 0. 11 says del into del cross A, which is 0. It says the divergence of the 0 of the core rather of A is 0. And the last but not the least says die cross of dev cross A is the same thing as the of A dot A minus the square A. So let's take note of all these rules. We'll be applying them as time goes on. Are we together? We need a
Yes,
response.
sir.
Okay. So let's look
Yeah,
at the
yeah.
example, the gradient. Let's give an example of the gradient. The gradient, I'll look at example here. Number 1 example says if phi of x, y, z equals to 3x squared y minus y cubed z squared. The question says find del of phi or grad phi at the point one minus two minus one minus one. So what does it mean? How do we solve this one? It's very simple. So all we need to do is the solution will be the phi del of phi will be d dxi, don't forget, plus d dyj plus d dzk into all our phi. Our phi is 3x squared y minus y cubed z squared. Meaning, anywhere you see where we have phi, you multiply, you put those operator there and those function there. We have it to be d, let's say I is d dx of phi. Our phi is 3x squared y minus y cubed z squared. Then plus j will be d dy of 3x squared y minus y cubed z squared. Plus k. D dz will be what? 3x squared y minus y cubed z squared. So what it simply means is differentiate with respect to x for I, differentiate with respect to y for j, and differentiate with respect to z for k. That is the meaning of what we're about to do now. So for y, for I, we have to differentiate with respect to x. When somebody should tell us, when you differentiate with the whole function here, let me see whether you are following us. Differentiate with the whole function with x, with respect to x. I'm listening.
Yeah. 6x.
6xy.
That's 6xy.
Okay. 6xy. Okay, good. Is that all?
Minus y cubed z square.
Which of them?
That's for high.
The next
That's for
for
I.
I
Differentiate I.
is 6xy.
That should be 6xy.
That's why.
Do we all agree?
Yes, sir.
Yes.
Okay,
Yes,
good.
sir.
Yes,
So
yes, yes.
let's solve the second one with respect to j.
That's a
3x squared. G.
3x squared
3x squared.
minus
3y squared.
minus 3y
Minus
squared
3y
z
squared.
squared. Do we agree?
Yes, sir.
J. So then we need z, the third one.
Minus
So it will be minus
minus
y3.
2y cubed z.
2y, yeah.
This is with k. Is it 2 or y or 3? This is supposed to be 2.
2.
Because z raised to power 2, right? So we have it to
Yes,
be
sir.
we have it to be 6xyi plus, put this one into bracket, x squared minus 3y squared z squared g minus 2y cubed z. Okay. Remember, we are given points. At points s equals to 1, y equals to minus 2, then z equals to minus 1. So substitute it here. You have 6 of 1 minus 2 I plus 3 of 1 squared minus 3 of minus 2 squared minus 1 squared j. Then minus 2 of minus 2 cube negative 1 k. So if you solve this one very well, what do you have for high? I we have minus 12i.
Minus 12i.
Do we all agree?
Yes, sir.
Yes, sir.
Minus 12i. Then this 1 squared,
It's
what
one.
do you have here? Let's say
Times
plus. Here we have 3. This is 4. Okay, let's write it 3 minus, which is plus.
minus
Okay,
12.
don't let
12.
me put it plus. 3 minus, which is minus 2. Okay. 3, 4, 1. Right? J.
Yes, sir.
This is 2 in brackets minus 8 minus 1. Okay. So which is minus 12i. This is 12 minus 3. Minus 9j. This is minus 16k. Do we have the same thing?
Yes, sir.
Yes, sir. Minus 16k.
Minus 16k, correct. Any question, please? So they can also ask us to find the unit vector of this particular one. Okay, let's solve one more question. Then probably the next class we continue from there to divergence. Are we tired?
Let's solve one more, sir.
Okay, let's look at it. It said find the directional. Anytime you hear this word directional derivative, they are talking about unit vector must be involved. Please take note of that. Of phi equals to x squared yz plus 4xz squared at 1 minus 2 minus 1. In the direction two I minus j minus 2k. So how do we solve this one? You already have phi. They are still talking about directional. So the solution will be talking about del phi equals, we have our del multiplied by phi. Our phi is x squared yz plus 4xz squared. So I know it to be I d dx of phi x squared yz plus 4xz squared plus j dy of x squared yz plus 4xz squared plus k d dz of x squared yz plus 4xz squared. So how do we solve this one now? Let's solve this one with respect to x. Can someone differentiate I with respect to x for me? I'm waiting for us, please.
2x yz plus 4z squared.
Good. I. Let's look at the j. J with respect to y. It will be x squared z. J. Do you agree with me? K with respect to z. It will be s
X
squared y
squared z
plus 8xz. Okay. So the next thing we need to do now is substitute s equals to 1, y equals to -2, z equals to -1. Substitute them here. So what do we have? We have 2 of 1, -2, and 1, -1. I plus two x. So we have x squared, right? We have 1 squared and -1. Everything j. So sorry, we've not finished this one first. Remember, this is plus 4 -1 squared. Everything is I. So plus, let's look at the j. J is 1 squared -1 j plus k. Now we have 1 squared -2 plus 8 1 -1 everything k. So when you solve this one very well, you have at the end of the day, you will have 8i minus j minus 10k. Don't forget at 1 minus 2 minus 1. That's why you have that. Then let's look at the unit vector. The unit vector in the direction of 2i minus j minus 2k is, remember we are given the direction 2i minus j minus 2k. Take note of that. Is a, our a, we write the small a as a unit vector to be 2i minus j minus 2k divided by square root of 2 squared plus -1 squared plus -2 squared. So this will give us 9. Square root of 9 is 3. It simply means we have 2i minus j minus 2k over square root of 9, which is equals to 3. Don't forget. So we now have it to be 2 over 3i minus 1 over 3j minus 2 over 3k. You can see the difference. So that, then we now use it to solve.
Go, sir.
Yes, go ahead.
Sorry, I don't know. Maybe it's my network. Please, the 2i minus j minus 2k. Where did it come from?
From the question. That's
Okay,
the
so from the
direction we are
question.
given. Look at
Okay,
it.
okay, yes. Okay, yes, I can see it. I can see it. Sorry, sir. Sorry.
No, it's okay. So it's good you at least you call our attention so that you guys are following. Then they require directional derivative is we have del phi dot a. Del phi dot a. Don't forget we know del phi. We calculated it. So it's going to be del phi will be 8i minus j minus 10k dot 2 over 3i minus 1 over 3j minus 2 over 3k. So dot component by component, don't forget. So for component by component, we have 8 multiplied by 2 over 3 plus 1 multiplied by 1 over 3 plus 10 multiplied by 2 over 3. So at the end of the day, we have this 16 over 3 plus 1 over 3 plus 20 over 3. We have it to be 37. That is what they ask you to calculate. Please take note of that. Any question? Any question, please? Let me stop sharing.
Sir,
Yes.
yeah, can we leave it like that, or we should
Break it
just say
further.
37 divided by 3? Okay, yes, or we should break it further.
If you want to break it further,
As in,
just use
that
your,
would
you can use
be
your calculator to
okay.
say 37 divided by 3. That's all. Or you leave it that way.
3. Okay,
Remember,
sir.
can 3 go in
Okay, sir.
37 free of charge?
No.
No, sir.
So it's better you can punch your calculator or leave it this way. Both options will be there in the marking guide.
Okay, sir.
So how about using mixed fraction, Beacon?
Anyhow, depending on yourself, anyone you choose to use, they are all there. But I don't think you have time to be doing that. Or do you think you have time to be doing that?
No, sir.
So that's why, does it make sense anyway, what we've been doing so far? Does it make sense?
Very well. The way you explained it is very, very understanding. We just hope we see something similar to this on the